Hello everyone, welcome back to another video of our multi-threading in Java series. In today's video, we are going to start solving problems which comes in the hard category in our list. We have already solved all the easy and medium level problems. So without wasting any time, let's start with our first hard problem, which is the reader-writer lock problem. Let's start by clearly defining the problem we are trying to solve. We have a shared resource, let's say a simple integer for now, n is equal to 2. But it could be a hash map, a file, a configuration object, a database object, or anything that lives in memory and is accessed by multiple threads. The threads accessing this shared resource fall into two categories. The first category is readers. Readers only read the data. They don't change anything. So the key insight here is, if two threads are only reading, then they can never corrupt each other's work. Correct? So reading is a non-destructive operation. Two readers, or in fact more than two readers, can safely run at the same time without any issues because their work is only to read the value. The second category is writers. Similar to readers, there can be multiple writers as well. So the writers modify the data, and when a writer is active, nobody else should be reading or writing simultaneously, because that would lead to inconsistent state or corrupted data. Now what do I mean by this? For example, if a writer is modifying the value of n from 2 to 3, and another writer at the same time is writing n is equal to 4, then it is not guaranteed whether the final value of n will be 3 or 4. Moreover, if a writer is writing something, we also don't want any reader thread to come in between and read at the exact moment, because we will be unsure whether reader has read the previous value or the updated one. Correct? So the rules of reader-writer access are these 5. So the first rule is multiple readers can read at the same time. Correct? The second rule is one writer can write when nobody else is active. Nobody else includes reader as well. So if a single writer is writing, neither another writer should write and nor any reader should be allowed to read. Correct? The third rule is a writer cannot write while the readers are reading. We just saw. The fourth is a reader cannot read while a writer is writing. Correct? And the fifth is two writers cannot write simultaneously. Now these rules might seem simple, but implementing them correctly and efficiently is where the challenge lies. The key word here is efficiently. So we have to implement this complete scenario by keeping performance in mind. Correct? So let's go on our IDE and try to solve this problem using a simple synchronized wait and notify all. So what we will do initially? Initially, we will create a shared resource. Shared resource will hold an integer value, and the shared resource class will have two methods, a read method and a write method. So let's code it. So let's create a class named shared resource. It will have an integer value and two functions, read and write. Correct? Let's implement our read function and write function. Correct? So we have a resource data whose value is equal to 0. Correct? There is a read function. So the read function will first print the thread name has started reading. Then we have written thread.sleep100 to simulate a reading work, right? Then we have printed finished reading and we have returned whatever data the read function has read. Similarly, in our write method, the first line is thread name started writing. Then we will simulate the write using sleep method, and post that we'll write this value in our shared resource, and then we'll print thread name has finished writing. Correct? Now let's go ahead and implement our main method. So in our main method, we'll have a shared resource. Now let's create 5 threads, 4 of which will be readers and 1 will be writer. Correct? So 4 reader threads, what will write? Correct, and let's do shared resource dot read for all of these 4 threads, and we'll have 1 writer thread. Correct? We'll write the value equals to 1 and executor service dot shutdown. Now let's go ahead and run this program and see the output. Right? So if you see, readers and writer overlap here. You can see started reading, started reading, started reading, started reading, and started writing in between. So essentially what is happening? The writer can modify the data while reader is reading. Reader hasn't finished the reading, and in between writer is going and writing. The problem that we are trying to solve. So this is a race condition. The output is unpredictable and incorrect. So we definitely need synchronization. Now let's apply the first and most obvious tool, which is the synchronized keyword. Correct? So let's go ahead and write synchronized on our functions. Synchronized and synchronized, right? Let's see the output. So thread 1 has started reading and finished it. Post that when there was no reader and no writer, then a writing has started. When the writing has finished, again reading started, reading started, reading started, and all of them ended in sequential manner, right? Much better, right? Threads execute one at a time without any overlapping. The output is now correct and consistent, no race condition and no corrupted data. But now let's look at this from a timing perspective. One of the words we used on our blackboard is we have to implement this efficiently. But let's see the timing here. So if you see, these 3 reading operations are happening sequentially, right? But as already discussed, reading can happen parallelly as well, correct? So thread 4, thread 3 and thread 2 can read parallelly to save time and to improve performance, correct? There is absolutely no reason reader 4 and reader 3 couldn't have run at the same time, along with reader 2 as well, right? So if all 4 readers can run concurrently, they would all finish in lesser time, almost 2.5 times faster than the actual time taken by this program. In real world application, if you think of a product catalog which is read by thousands of users per second. So those difference could compound up to 10x, 50x or 100x, right? So this performance improvement is very important. Now the problem with this is synchronized uses a single intrinsic lock, and that lock is the object's monitor. Now this is correct tool for many situations, but for our reader writer problem, it's too blunt of an instrument. Let's see on our blackboard what does synchronized provide and what we actually need. So synchronized lock mode is exclusive only. What does this mean? This means thread 1 holds the lock and every other thread wait, right? So even if thread 2, thread 3, thread 4 only wants to read, still they will have to wait, right? So this is the limitation with synchronized. What we actually need? We need 2 lock modes. What are those lock modes? There should be 2 lock mode. The first one is read. The read lock mode should be shared one so that multiple threads are allowed to read simultaneously. But the second lock mode, which is the write mode, should be exclusive. Exclusive in the sense only one thread can write and all the readers and the writers except the writing thread should be blocked. Correct? Before we touch the keyboard, let's figure out the code for how will our new lock look like. Basically, we want a lock that allows multiple readers simultaneously but gives writer exclusive access. So the first question is, what state do we need to keep track of? Think about it. At any point of time, we need to know two things. The number of readers, how many readers are currently active, and another variable which is writer active, whether a writer is currently writing or not. That's it. Just two variables. Now let's think about each operation one by one. Whenever a reader wants to read, what is the kind of lock we want to acquire? So suppose our lock's name is lock read, right? So when is it not safe for a reader to enter? Only one case, when a writer is actively writing, right? So if a writer is actively writing, then the reader will have to wait, otherwise it is safe to enter. Just increment the reader count, acquire the lock and proceed, right? Now while releasing the read lock, what will reader do? Reader will decrement the count because the reader has already read the variable, right? Post that. If readers equals to 0, then we will notify all. Why this? Because if it is the last reader leaving, then we have to wake up all the waiting threads. So if there are 4 readers, R1, R2, R3, R4, R1 has done reading, R2 is finished reading, R3 is finished reading. If it is the last reader which has finished reading, what we will do? We will go ahead and write notify all, right? So all the sleeping threads, including the writer's thread, will wake up, check their condition, whether it is safe to write or not, and then it can go ahead and write. Correct? So how will our writer lock look like? A writer wants to enter. Now this is very strict. When is it not safe for a writer to enter? It is not safe for a writer to enter in 2 cases. If any reader is active, that means reader's count is greater than 0, or another writer is writing, means writer active is equals to 0, right? If that is the case, then we will wait, or else that particular writer will go ahead, set the writer active variable and acquire the lock and start writing. While unlocking the lock, what it will do? It will go ahead, set the writer active flag to false and notify all. Why it will do notify all? It will again wake up all the waiting readers and writers. They will again go ahead and recheck the conditions, whether they want to read or write, they will decide. Correct? Now let's go ahead and implement this lock in our IDE and see how it works. Right, so we have created a class custom read write lock. Inside custom read write lock, I have written the exact same functions which we discussed on our blackboard with all the comments here. Let's see. We have a lock read method, right? It is a synchronized method which will wait as long as the writer is active, and as soon as the writer is inactive, it will go and increment the count and register this reader as active. Correct? While unlocking, reader minus minus. If the number of readers concurrently reading is 0, then we will go ahead and notify all. Correct? For lock write, there is a stricter condition. And to unlock, we will just set write active equals to false and notify all. Now, how will this be used in our shared resource? In our shared resource, we will have again 2 methods, read and write, and 1 data on which we want to work. Correct? We have created an instance of that lock class, and inside our read method, what we have done lock.lock read. Correct? Once it will do lock.lock read, this method will be called. Correct? It will check whether writer is active or not, readers plus plus, and then it can move forward and start reading. Right? Thread.sleep 100. then this finished reading and return data. Correct? The same thing in our write function as well. What we have written, log write. We have set the data, system.out finished writing. In our finally block, we have written log.unlock write. Correct? Now let's go ahead, run it, see the output, and then discuss further. Correct? So here we have 4 readers thread and 1 writer thread. And we'll run it. Right? Now see the output very carefully. All the 4 readers are able to start reading in parallel. Correct? Why are they able to start reading in parallel? Because as soon as they write log.log read, this synchronized method is called. Once the reader is registered, we get out of this synchronized method and the lock is released. So another reader is completely free to again call this lock read method. That is why all the 4 readers are able to work parallelly. But the writer thread is not able to interleave this reader's thread, not able to interrupt this reader thread. Why? Because as soon as a single reader has registered itself, our writer, while readers greater than 0, this condition will become true and our writer will go ahead in waiting state. And as soon as all the readers haven't finished reading, right, until then notify all will not be called. Therefore, all the readers are able to read parallelly, and post that our writer is able to write. So we have solved the problem and our output looks perfectly fine. But now let's run it for infinite amount of times. So let's go in our main class, correct? And write here while true. So for infinite amount of time, all the 4 threads will go ahead and continuously keep on reading while our writer thread will go ahead and continuously keep on writing. Try to keep writing, correct? Now let's go ahead and run it. Right? Now let's stop this and let's see the output. So the output is all the 4 threads have started reading, 2 of them has finished, then again those 2 has started reading, then this 4 and 3 has also finished here, correct? Then started reading, finishing. The bottom line here is, if you see, everything is reading. There is not a single write registered yet, correct? Even though we have given complete freedom to our writer to go ahead and write, it is not able to write. Why? Is there some issue in our code? So basically, our code is correct, but we have introduced a separate issue which is called starvation. Our writer is not getting chance to write in our shared resource because of the stricter condition that we have kept. When readers are greater than 0 and writer active is equal to false, correct? Because of this stricter condition. Let's go on our blackboard and see it quickly, right? So what is happening? R1, R2, R3, R4. This is our shared resource and this is one writer. So R1 is reading, then R2 is reading, R3 is reading, R4 is reading. Our readers is equal to 4, correct? And writer active is equal to false, correct? So our writer is in waiting state currently, correct? Now what happens? There are 4 readers, R1, R2, R3 and R4. They have incremented the number of readers reading parallelly on the shared resource to 4. Writer active is equal to false and our writer is in waiting state. Now what happens? Suppose reader 1 and reader 2 has finished reading. So R1 and R2 has finished reading. Therefore, the value of readers will change to 2 because they have reduced the number of readers from 4 to 2. Correct? Now, even though the value of readers is reduced to 2, the writer will not be able to go ahead and write it because still the value is not 0. Now, before the value turns 0, these readers which have already finished reading again go to the shared resource, check the condition whether they can read or not. Whether they can read or not, is the condition true? Yes, the condition is true because there is no writer which is writing currently. So these readers can also read in parallel, correct? Therefore, the value of readers again increment from 2 to 3, then 3 to 4, right? Then R3 and R4 finishes reading. When R3 and R4 finishes reading, the readers value, so it is very tough for the value of readers to turn to 0 because there are more number of readers, correct? Therefore, it is highly unlikely that this condition, the writer's strict condition, will be met and writer will get access to write. Thus, we have starvation for the writer here, correct? Now, to fix this, there is a very simple fix that we need to do. When R1, R2, R3, R4 are reading, and at that time if any of the writer goes ahead and tries to write on the shared resource, what we will do? We will increment, we will store the number of writers which are currently in waiting state. So the number of writers currently in waiting state, we will create writer waiting, maybe another variable, and we will increment this writer waiting to 1, right? Now, reader will have more strict condition that before it again goes on and reads from the shared resource, along with writer active is equal to false, the number of writers waiting should also be equal to 0. There should not be a writer which is already waiting from the previous iteration, right? So this is the stricter condition. Now we will enforce on reader and we will make a new variable, writers waiting, which will have the number of writers currently waiting for the shared resource. This will fix the starvation for writer. Let's go ahead and make this small change on our IDE, right? So I have made that change, and what does that change look like? Private int waiting writers. Waiting writers is equal to 0. We have introduced this, correct? Before locking, what will the writer do? Waiting writers, it will increment, correct? It will not be able to acquire the shared resource, therefore it will go ahead in waiting state, correct? And after suppose it finishes writing somehow, then it will do waiting writers minus minus. There is no writer waiting, correct? And the reader condition, we have made it stricter. For reader to access the lock, the writer active should be true and there should not be any waiting writers, correct? So if we run this program, let's stop this, correct? And let's see what happens. All the 4 readers have been reading parallelly. As soon as reader finished, the writer has started writing. Now there is another problem. Now the writer has started writing, but reader is not able to acquire the lock. Only the writer is able to write again and again and again, right? Now there is a reverse problem. Initially, there was more probability of writer to get starved, and now you could potentially starve the readers, right? If writers keep coming in constantly, again and again, this particular condition keeps on getting true. The writer comes again and again, waiting writer's value will be more than 0, right? And every time a reader tries to acquire a lock, waiting writer is greater than 0 and it goes ahead in waiting state, right? So no matter whatever we do, either writer is starving or reader is starving. So we need a middle ground, right? We need some fairness to be introduced here. Now definitely we can code it, but it will become more complex. So instead of coding it ourselves, Java itself provides a perfect balance between these two starvation, which is called reentrant read write lock. Yes, if I show you, that is reentrant read write lock. Reentrant read write lock, when it runs with a fair mode, it uses proper FIFO queue, which is why building that from scratch is significantly more complex. And this is the class that will solve the starvation problem for both readers and writers, right? So what happens when reentrant read write lock comes in picture? This happens. So when we created our custom lock without any fix, at that time reader was preferred and writers were starving. Then when we introduced our fix, writer was preferred and readers were starving. But when we will use reentrant read write lock at that time, it uses a first in first out fair mode using a queue internal implementation, and therefore at that time nobody will starve. Now what is exactly inside this class, how this class works, and how this class stops from starving, that we will see in our next video. And also this reentrant read write lock, even this has some problem which is solved by another thing which is called as stampede lock. Both these things we'll see in our next video. I hope you like this video. Until the next video, stay safe, stay healthy. Bye.